Picture a planet located 635 light-years from Earth, a world where day and night could stretch on eternally, and vast oceans dominate its surface. This is Kepler-22b, one of the most captivating exoplanets ever discovered. It appears to have all the right conditions to become a second Earth. Yet beneath its promising facade lies a set of mysteries that could transform it into either a cradle for life or a realm of unimaginable extremes. In 2011, while scanning the vastness of space, NASA's Kepler Space Telescope made a groundbreaking discovery: a planet located within the habitable zone of its parent star. This world would soon be known as Kepler-22b. Could humans survive on Kepler-22b? The discovery was made using an indirect method. Every time a planet passes in front of its star, it causes the star's brightness to dim slightly, a telltale sign of a planetary transit. This technique, known as the transit method, not only reveals the presence of a planet, but also allows scientists to determine key characteristics such as its size, orbital period, distance from the star, and even clues about its atmosphere. Kepler-22b orbits a star designated Kepler-22, located approximately 635 light-years from Earth, or about 3 quadrillion miles away. Kepler-22 is a yellow dwarf star, very similar to our Sun in size, radius, and age, which is estimated to be around 4 billion years. However, this star is about 20% dimmer than the Sun, which means it cannot be seen with the naked eye from Earth. The distance between Kepler-22 and its planet is also intriguing. Kepler-22b orbits its star at a distance 15% closer than Earth does to the Sun. If Kepler-22b were in our own solar system, its orbit would place it somewhere between Earth and Venus. In such a location around our Sun, the planet would likely become a scorched, lifeless world like Venus due to intense solar radiation. But the situation here is different. Since Kepler-22 is 25% less luminous than the Sun, Kepler-22b receives less heat, even though it's closer, potentially allowing temperatures comparable to Earth's. That is, assuming Kepler-22b rotates around its star in a way similar to how Earth rotates around the Sun, it could maintain Earth-like average temperatures. However, if its rotational axis is tilted dramatically, like Uranus, the planet could experience extreme seasonal changes, ranging from brutal winters to scorching summers. Alternatively, if Kepler-22b is tidally locked, one hemisphere would always face the star in constant daylight, while the other remains shrouded in eternal darkness. Such a division of light and heat would create starkly different climates across the planet and could greatly influence where and how life might emerge. Let's explore deeper into the possible climate dynamics of Kepler-22b, assuming the planet is tidally locked to its star. On the sunlit side, conditions might initially seem ideal for life. With constant illumination, vast oceans could help regulate temperature and prevent the surface from overheating. In such an environment, photosynthesis-like processes could evolve, allowing organisms to harness the steady supply of stellar energy. However, there's a potential complication. If Kepler-22b is covered largely by water, continuous sunlight would lead to excessive evaporation on the dayside. This would intensify the greenhouse effect, possibly thickening the atmosphere with water vapor, generating dense cloud cover, and unleashing violent storms. Such extreme and unstable conditions could make it difficult for complex life forms to survive or evolve on the sunlit hemisphere. Now consider the dark side of the planet, a realm of endless night with no direct light or heat from the star. At first glance, it might seem inhospitable, but Earth has shown us that life can thrive even in total darkness, such as near deep-sea hydrothermal vents. On Kepler-22b, organisms in the dark side might rely on chemosynthesis, deriving energy from chemical reactions rather than sunlight. Microbial life like this could form the base of a unique ecosystem, feeding off chemical compounds rising from the planet's interior. Over time, animals in this region might evolve bioluminescence, the ability to generate light to help them navigate, attract food, or communicate. In a world with no natural sunlight, this glowing adaptation would be crucial for survival and interaction in the pitch-black environment. Yet despite these fascinating possibilities, the dark side would likely be too harsh for larger or more complex organisms to flourish. Which brings us to perhaps the most intriguing region on Kepler-22b, the Terminator Zone, the narrow band where day meets night. Here, the temperature could be more moderate and stable, as the intense heat from the day side and the cold of the night side counterbalance one another. If the planet possesses an atmosphere, this region could sustain liquid water on the surface, forming rivers, lakes, or shallow seas. This delicate thermal balance makes the Terminator Zone the most promising area for life to emerge and evolve on Kepler-22b, potentially supporting complex ecosystems unlike anything on Earth. Perhaps in time we may discover the first signs of extraterrestrial life right there in that fragile zone of balance between light and darkness. If Kepler-22b possesses an Earth-like atmosphere with a moderate greenhouse effect, surface temperatures could reach a comfortable 22 degrees Celsius, 72 degrees Fahrenheit, ideal for liquid water and potentially even life. But the reality may be very different. If the planet lacks an atmosphere altogether, surface temperatures could plummet to -8 degrees Celsius, 17 degrees Fahrenheit, making it a much colder and more hostile world. On the other hand, if its atmosphere resembles that of Venus, thick and saturated with carbon dioxide, the planet's surface could become unbearably hot, reaching up to 460 degrees Celsius, 860 degrees Fahrenheit. Fortunately, some studies suggest that Kepler-22b may host an ocean capable of stabilizing its climate, much like Earth's oceans regulate temperature over long time periods. These oceans could absorb heat during warmer periods and redistribute it more evenly, helping to maintain a more balanced environment across the planet's surface. It's also believed that Kepler-22b contains an abundance of water, with oceans that may cover most of the planet's surface. These hypothetical oceans are estimated to be about 160 feet, 50 meters deep on average, shallow compared to Earth, but significant considering the planet's size. However, since Kepler-22b is 2.4 times larger than Earth, finding solid land could be quite difficult. Any exposed terrain might be scattered or submerged. Even if you manage to land on solid ground, moving around would be a tremendous challenge due to the planet's intense gravity. With an estimated mass 36 times that of Earth, Kepler-22b likely exerts gravitational force about 6 times stronger than what we experience here. To put that into perspective, if you weigh 175 pounds on Earth, you'd weigh over 1,050 pounds on Kepler-22b. Even standing upright would require extraordinary strength. Walking or lifting objects could be nearly impossible without assistance. Now imagine wearing a standard spacesuit, which on Earth weighs around 290 pounds. On Kepler-22b, that suit would weigh nearly 1,700 pounds. Under such extreme conditions, astronauts would need to wear powered exoskeletons, robotic frameworks designed to support the back, legs, and arms. These exoskeletons would be essential to counteract the immense strain on the human body and to enable even basic movement. Without this kind of assistance, your mission could end the moment you step out of the spacecraft. Your body simply wouldn't cope with the crushing force of gravity. Even worse, falling into a small ravine or depression could be fatal. With gravity so high, a short fall might feel like dropping from a skyscraper. And whatever you do, don't fall. Be extremely cautious near any slope or depression. Even a small ravine could trap you forever in Kepler-22b's crushing gravity. With gravity so intense, your free fall speed could exceed 120 miles per hour. Falling just 160 feet could send you to the bottom in less than a second. Gravity wouldn't only affect human explorers, it would shape every aspect of life on Kepler-22b, from the tiniest microbes to the largest native organisms. Plants, for example, would likely be short and stocky, with thick, sturdy stems designed to withstand the constant downward pressure of extreme gravity. Rather than growing tall, they develop compact, dense foliage, a strategy to reduce the risk of structural collapse or injury from strain. Their root systems would probably grow deep and wide, anchoring the plants securely into the ground and helping them resist gravitational stress. This underground network would not only provide physical stability, but also ensure efficient access to nutrients in such a demanding environment. The only life forms likely to reach significant size might be aquatic, where the buoyant force of water would help counteract the crushing gravity. But diving into those oceans wouldn't be wise, not until we can confirm the water's chemical composition and toxicity through proper analysis. If complex animal life exists on Kepler-22b, it would be highly specialized, built to survive under constant pressure and minimal mobility. Creatures here would likely be low to the ground, with broad, muscular bodies and multiple limbs to help distribute their weight evenly. Their movement would be slow, deliberate, and highly efficient, conserving energy in an environment where every step demands immense force. To endure the stress of gravity, many animals might evolve thick exoskeletons, rigid outer layers to protect and support their internal organs. These exoskeletons would need to be both strong and flexible, made from advanced biological materials similar to chitin or calcium carbonate, but far tougher. They would serve multiple roles: structural support, protection from predators, and a barrier against deformation from environmental pressure. Some species might even use their exoskeletons for thermoregulation, with adaptations to retain or dissipate heat in climates with wild temperature swings. Underwater life forms might grow larger, benefiting from buoyancy, while surface creatures would likely remain compact and heavily built. As for flying animals, they're probably non-existent. The planet's gravity is simply too strong to allow for sustained flight. Even if wings evolved, the energy required to lift off would far exceed what biological systems could generate in such a high-pressure world. These ideas remain speculative, based on theoretical models and hypotheses developed by astrobiologists and planetary scientists at NASA and other institutions. At present, we lack the observational capabilities to confirm these theories. Still, there's hope that future advancements in technology will allow us to study Kepler-22b in greater detail, and perhaps detect signs of life, if any truly exist. If, however, our assumptions about gravity are overestimated, and it turns out to be only twice Earth's gravity, the planet may be far more feasible for colonization than we currently believe. In that case, the primary challenge would no longer be physical adaptation, but rather the vast distance separating us from the planet. Kepler-22b lies 635 light-years away, a short distance on a cosmic scale, yet still unreachable by current human spaceflight capabilities. As of now, the fastest object ever created by humans is NASA's Parker Solar Probe. During its closest flyby of the Sun, it reached a speed of 430,000 miles per hour, or roughly 119 kilometers per second. Although that speed is staggering, it still amounts to just 0.064% of the speed of light. At that pace, it would take an astonishing 992,000 years to reach Kepler-22b. Not exactly an ideal travel timeline, especially if you're not planning to wait 1,000,000 years. Reaching such remote destinations would require a radically new approach to propulsion, and NASA scientists are actively exploring this challenge. Researchers are investigating nuclear fission and fusion propulsion, which, in theory, could accelerate spacecraft to 10% the speed of light. Even then, the journey would still span over 6,350 years. For now, colonizing distant exoplanets like Kepler-22b remains beyond our reach until a revolutionary leap in space travel is made. These remain educated assumptions, and we make no definitive claims about how conditions on Kepler-22b will ultimately unfold. There is still much to discover about the kinds of life forms a planet like Kepler-22b could potentially support or generate. Earth has shown us that life can thrive in extreme environments, reminding us that even on seemingly hostile planets, life may still find a way. With that in mind, let's now turn our attention to other fascinating exoplanets discovered by the Kepler telescope. Kepler-452b, a promising twin of Earth. In the search for potentially habitable worlds, scientists often focus on finding Earth twins, planets that closely resemble our own in size and conditions. Such planets typically have a similar size to Earth, which increases the likelihood of possessing a solid rocky surface. They must also orbit a star similar in size and energy output to our Sun, and stay within the habitable zone, where temperatures allow for liquid water. Kepler-452b was the first Earth-like planet discovered orbiting a Sun-like star, and it may be one of the most promising candidates for habitability. Back in 2015, scientists regarded it as the most Earth-like exoplanet ever discovered, and for good reason. Kepler-452, like our Sun, is a G-type star with a comparable temperature, but it's 1.5 billion years older. Although it's slightly brighter and larger than the Sun, the amount of solar energy that Kepler-452b receives is only 10% more than what Earth gets. With a size about 1.6 times that of Earth, there's more than a 50% chance that Kepler-452b is a rocky super-Earth. Its orbit is also remarkably similar to Earth's, about 5% farther from its star than Earth is from the Sun, yet still well within the habitable zone. Scientists speculate that Kepler-452b may have had a head start in the development of life, having spent an estimated 6 billion years in the habitable zone. Of course, this assumption only holds if Kepler-452b possessed all the right environmental conditions for life to arise. Recent research suggests that Kepler-452b does meet some of these key conditions. One study found that if its atmospheric CO2 levels are similar to Earth's, the planet could indeed be habitable. Could we live on Kepler-452b? So what might life actually be like on this distant alien world? Given that Kepler-452b is more massive than Earth, it would likely exert stronger surface gravity. In such an environment, humans would have to adapt to increased weight, possibly feeling twice as heavy as they do on Earth. At first, mobility would be difficult, but over time, human physiology could adapt, paving the way for a gradual evolutionary shift. A former NASA astronaut suggested that, much like firefighters accustomed to heavy gear, our bodies would grow stronger through regular physical exertion in high gravity. Over time, our skeletal systems might develop increased resilience, helping us resist the persistent gravitational pull. Future generations could be born with naturally stronger builds, surpassing the physical resilience of children born on Earth. Not everything would feel alien. Thanks to its star's similarity to our Sun, Kepler-22b's sunlight and temperatures might feel familiar. If conditions are right, plant life could still rely on photosynthesis, growing at a pace similar to that seen on Earth. Scientists also theorize that the planet could have a dense atmosphere, liquid water, and even active volcanic activity. If these predictions hold true, Kepler-22b could be an excellent Earth 2.0, but perhaps not permanently. Researchers warn that it may face a runaway greenhouse effect in about 500 million years, similar to Venus, where trapped CO2 made the atmosphere 90 times denser than Earth's. A habitable world too far. Still, 500 million years is a generous window, enough time for humanity to potentially colonize Kepler-22b and call it a second home. Kepler-22b is undeniably exciting, but it's not the only promising Kepler planet, and it's also incredibly distant. To put its distance in perspective, even light itself would take 1,800 years to travel from Earth to Kepler-22b. Even if we developed the technology to survive on Kepler-22b, we would still face the daunting question: how do we get there? Without faster-than-light travel, the vastness of space remains our greatest barrier. It's a humbling reminder that our knowledge of distant worlds may always outpace our ability to reach them, unless we unlock new physics or develop technologies that currently live only in science fiction. Now consider the fastest spacecraft humans have ever built, NASA's Parker Solar Probe, which, during its closest solar approach, reaches a blazing 120 kilometers per second. That's an extraordinary speed by our standards, yet it's still only 0.063% the speed of light. At that speed, a direct journey to Kepler-22b, located 1,800 light-years away, would still take a staggering 2.8 million years. Kepler-186f, an Earth-sized world at the edge. Located 500 light-years from Earth in the constellation Cygnus, Kepler-186 is a red dwarf star. It was in this stellar system that astronomers discovered the first Earth-sized exoplanet orbiting a distant star within its habitable zone. Since that discovery, astronomers have grown increasingly confident that many other worlds may exist with similar diameters to Earth and conditions suitable for liquid water. Kepler-186f is only slightly larger than Earth by less than 10%, and it completes one orbit in about 130 Earth days. This alien world lies near the outer edge of the habitable zone around its host star. As a result, Kepler-186f receives only about 1/3 of the solar energy that Earth receives from the Sun. This makes its surface conditions more comparable to those found on Mars. Though its position near the edge of the habitable zone suggests cooler temperatures, this doesn't rule out the possibility of life, especially if the planet has the right atmospheric conditions. Could a thick enough atmosphere help trap and distribute heat, making Kepler-186f more temperate than it appears? That's a question scientists are eager to explore. In fact, Mars once had a thicker atmosphere and liquid water. If Kepler-186f followed a different evolutionary path, it might still harbor the right ingredients for life today. Can Kepler-186f keep its water liquid? However, instead of being a disadvantage, this energy deficit might actually offer a unique advantage. Red dwarf stars are notorious for their intense solar flares, which can cause their brightness to double within minutes. But the star Kepler-186 is smaller, less massive, cooler, and significantly dimmer than the Sun. So even if this M-type star releases bursts of radiation, Kepler-186f may be far enough away to avoid catastrophic effects. The possibility of liquid water and life on Kepler-186f depends not only on its distance from the star, but also on its atmosphere. At its current orbital position, surface water may be frozen. However, because it's slightly larger than Earth, Kepler-186f could have a thicker atmosphere, capable of trapping and redistributing heat, potentially keeping water in a liquid state. The cold frontier, heating up Kepler-186f. The 4 other planets in the Kepler-186 system are only about half the size of Earth and have very short orbital periods, making them extremely hot and unlikely to support life as we know it. As of now, it would take approximately 780,000 years to reach Kepler-186f using our current technology. But imagine a future where we've developed spacecraft capable of traveling at 90% the speed of light. In that case, it would take just 550 years for our descendants to set foot on Kepler-186f. The red dwarf star Kepler-186 is smaller and about 25 times dimmer than our Sun. If you were standing on Kepler-186f at midday, the star would appear about as bright as the Sun does on Earth an hour before sunset. Scientists say the planet maintains a stable axial tilt, enabling it to have regular seasons and a consistent climate, just like here on Earth. Calculations suggest that this axial stability has persisted for tens of millions of years, contributing to long-term climate consistency. Such stability is critical since an erratic tilt could have catastrophic consequences, turning a habitable planet into a barren and hostile world. Just consider Mars, where an unstable axial tilt may have been a major factor in its transformation into a dry, lifeless desert. The search for the ideal Goldilocks planet continues, and surprisingly, some of the best candidates are found purely by chance. In 2020, Kepler-1649c was accidentally discovered during a reanalysis of older data after initially being misclassified as a false positive. We still know very little about Kepler-1649c, including its atmosphere. But since it receives about 75% of the starlight Earth gets and has a short 19.5-day orbit, its surface temperatures might be similar to ours. If Kepler-186f lacked a heat-trapping atmosphere, its surface could reach negative 38 degrees Fahrenheit. That might sound frigid, but Earth, without its greenhouse gases, would also sit at a chilly 0 degrees Fahrenheit. Even if its atmosphere were Earth-like, Kepler-186f would still need higher levels of greenhouse gases to maintain Earth-like surface temperatures. Kepler-1649c, the missed opportunity that mirrors Earth. Many other worlds, like TRAPPIST-1f, TRAPPIST-1d, Teegarden Star C, and TOI 700d, also resemble Earth in size or temperature, and they're much closer to us. Yet Kepler-1649c remains unreachable for now, as it would take around 470,000 years to reach it with current propulsion methods. But if we ever reach it, the journey may be worthwhile, because none of these closer planets match the rare combination of traits found on Kepler-1649c. This remarkable exoplanet potentially mirrors Earth's temperature and size, and it sits comfortably within its star's habitable zone. That makes it a truly exceptional discovery in the search for habitable worlds. The Kepler-1649 system also includes a second planet, Kepler-1649b, which is about 8% larger than Earth, but much closer to its red dwarf star. Interestingly, the 4 to 9 orbital resonance between the two known planets hints that a third planet may be lurking undetected in the system. Soon, next-generation space telescopes will provide better data to help determine how habitable these intriguing worlds really are. Kepler-442b, life in the light of an orange dwarf. Let's now turn to another fascinating exoplanet, located 1,100 light-years away in the constellation Lyra. Kepler-22b completes an orbit around its K-type star every 112 days, at a distance that is roughly half that between Earth and the Sun. This close orbit could potentially create several challenges for any life forms trying to survive there. Planets in close orbits are often tidally locked, meaning one side always faces the star, leading to extreme surface conditions. Fortunately, Kepler-22b lies just beyond the zone where the star's gravitational pull would likely cause tidal locking. K-type stars are generally dimmer than the Sun, and Kepler-442 is smaller and cooler by comparison. Kepler-442b is situated at an optimal distance, about 0.4 astronomical units, from its relatively calm host star. Scientists view K-type stars as a sweet spot for habitability. They're not as bright as G-type stars, nor as long-lived as M-type red dwarfs, but they offer a balanced combination of stability and lifespan. There are over 1,000 K-type stars within just 100 light-years of Earth. These orange dwarfs can shine for 15 to 45 billion years. While our Sun, lifespan approximately 10 billion years, will likely render Earth uninhabitable in just 1 to 2 billion years, orange dwarfs only brighten by 10 to 15% over their entire much longer lives. How habitable is Kepler-442b? So, just how promising is Kepler-442b in terms of habitability? Astronomers evaluate planets using various metrics, and a newer method, called the Comparative Habitability Index, CHI, offers a more refined approach than previous systems. This index considers factors like a planet's composition, favoring rocky worlds, and orbital eccentricity, which impacts the consistency of light and heat it receives. It also incorporates albedo, a measure of how much solar energy is reflected by the planet's surface and atmosphere. Together, these variables offer a more comprehensive view of a planet's habitability potential, even when its orbit isn't perfectly circular. Water worlds and the hunt for life. Unfortunately, Kepler-442b is too dim and small to be directly observed with current telescopes, let alone visited, since a trip would take 1.7 million years using today's fastest space probe. However, what we can do is examine its biosignature potential. One study on radiation levels across habitable exoplanets highlighted Kepler-442b as particularly noteworthy. It receives almost enough sunlight to sustain a sizable biosphere, possibly detectable by the James Webb Space Telescope, JWST. As JWST continues its observations of Kepler-442b, scientists also hope to expand its focus to two other intriguing planets in the same constellation. Within the Kepler-62 system, two planets sit nicely within the habitable zone. The other three orbit too close to the K-type star, making them too hot to support life. Scientists are especially interested in Kepler-62e and 62f, which appear to be water-rich worlds. These planets have Earth Similarity Index scores of 0.83, Kepler-62e, and 0.69, Kepler-62f, indicating notable Earth-like traits. Kepler-62e completes an orbit every 122 days, while 62f takes 267 days to circle its star. Kepler-62e likely has a thick, cloudy atmosphere and may possess a warm, humid climate that reaches even its polar zones. Such conditions make it an especially favorable candidate for supporting life. A 2014 study suggested that Kepler-62e may even have a large moon, which would further boost its habitability potential. Large moons are thought to aid the evolution of complex life by generating tidal forces that help stabilize a planet's rotation and axial tilt, which in turn influences its climate stability. Moons also serve as a protective barrier, helping to deflect or absorb impacts from asteroids and comets. Although Kepler-22f orbits farther out and likely has a cooler surface, it may still be capable of supporting life. A world without fire. Can civilization rise underwater? Even if the habitability hypothesis proves true, it's difficult to imagine a technologically advanced civilization developing on such a world. Key technological processes like metallurgy, which rely on smelting and combustion, would be nearly impossible in an environment devoid of dry land and flame. Still, the complexity of nature leaves room for the possibility of beings far more inventive than us. Perhaps these life forms could develop alternative technologies that exceed our own, even if they evolved entirely underwater. Instead of metals, such civilizations might manipulate organic compounds, crystals, or even bioluminescent organisms as tools and energy sources, building a form of technology we can't yet comprehend. Communication might rely on pressure waves, color changes, or complex chemical signals, replacing speech, writing, or digital screens. Perhaps the real limitation lies not in physics, but in our imagination. If life has already found a way to survive without light in Earth's deep oceans, who's to say it couldn't build an intelligent society in total darkness? If humanity were to send a message aboard the Parker Solar Probe to any intelligent beings on these distant exoplanets, they wouldn't receive it for another 1.85 million years. However, a radio transmission sent today would arrive in just 1,200 years, a blink of an eye on a cosmic scale. Though Kepler-22e and 62f may not be perfect Earth twins today, the dynamic nature of planetary evolution suggests they could undergo dramatic transformations over time. After all, Earth itself was once covered entirely in ocean, yet over billions of years it evolved into a diverse world of continents and seas. Researchers speculate that these exoplanets might one day mirror Earth, featuring a harmonious balance of land and ocean, shaped by slow but powerful planetary processes. And if flying fish can exist on Earth, it's not unreasonable to believe that life on these distant worlds, if it exists, could be just as creative and complex. We've just seen another world, but maybe what we're really seeing is ourselves. One of the biggest obstacles in exploring distant worlds is the sheer distance involved. But we may not have to wait for ultra-advanced telescopes to bridge that gap. Data from Kepler and the European Space Agency suggest that half of all Sun-like stars could host rocky, potentially habitable worlds, and some of them might lie within our cosmic backyard. This means there's a 95% chance that at least one Earth twin is quietly hiding within just 20 light-years of our solar system. Be sure to stay tuned to continue exploring the wonders of our planet and the vast cosmos beyond. Thanks for watching.